We have our game. Our game does work to some extent, but there's a problem with communication between the threads. One thread is controlling the UI, these buttons, these sliders, and the display of Corey on our screen, and the other thread is controlling his state of what direction he's going and move him. So let's combine the communication between the threads so that we can live in a more peaceful game world. So we're going to use a queue to put, as they're trying to talk to each other, the message will be put into the queue. So the thread will put a message in the queue, and then we will update the queue and use it. So let's go back down to where our game loop is right here. We're gonna we'll create a variable to update the queue. Update queue to make those changes that we want. And it'll just be queue, which is the library that we just imported. And it's something called a queue. Right? It's just holding the messages of the different threads. And how do you drop the message onto the queue? Well, it's a loop. And so we're going to want to update it. And so we'll go update queue.put, and it will update it. And this message doesn't matter right now. We just want there to be a message. So update is the message, but it doesn't matter at this point what the message is. And now we're going to use asyncio. Another package, import asyncio. Go down to where we have our thread here, right below our game loop. We're starting our thread. I just want to check for updates. So we're going to use an async Python function. It's just simply using the async keyword in front of the function. So it's def check underscore updates, name that we are defining ourselves. While true, we want something to happen, and it's pass. Okay. By using this Python keyword async, we can now have it await things or run in the background with a whole bunch of other processes. Okay, so we will try. So there's try and accept. We're going to try something. Update queue, which we just created. We'll get without waiting, and we're going to update the page. Page.update. If this doesn't work, it means the queue is empty. We'll pass it. And then we will put it to sleep. But because it's an asynchronous function here, because we use the async keyword, we have to use a wait to actually sleep it, or else the sleep will be running on a different process. So, okay, so it won't wait. Async IO. So it's a slightly different syntax for the sleep, but it's very similar, right? You just use async IO, and we'll have it wait for 0.1 second. And now we just need to run the asynchronous task, which is going to be, make sure it's lined up with this async right there. Run task from flet, and we will check the update. Okay, big moment. Is Corey going to make an appearance? Okay, he appears. I pressed it. He's moving. He's looking good. Can he go the other way? Oh, look at that. He's going the other way. What if I do? Oh, look at this. I can move him around now. I can probably have him like run around the house or something. Can I get him into the house? Boom, no collision detection yet. But there's boundaries. Wonderful. Okay, the goal is to teach you communication between threads, just a concept. So you're probably learning in school when you're in the CS program, and you're probably in the second year, you pass the Weeder courses, or maybe you're on that last course in a 3-quarter sequence. It's just a concept. We're not going very deep, but you'll have heard of it. You're like, oh, I remember using this, making this kick-ass game. All right, so the problem with thread communication, we've already covered it. The background thread updates the character position, but the UI thread must update the screen, which is the main one. And the UI updates must happen on the main thread. But how do they communicate? We're using the queue, which we just implemented, the queue. So the queue is like a mailbox, and it's a safe mailbox. It doesn't like mess with the other mail that's going on there. So we first create the queue, and the background thread puts a message in the queue. The main thread, queue.Get or queue.GetNoWait, will get the queue. And then multiple threads can use this state. We only have 2 threads, but it can scale. You can have a lot of threads, but it gets more complex. We're just using 2 so you can understand it. So it's like a mailbox. One person puts in the mail, another person checks the mail. In the background thread, to make this character move, we first handle the movement, and then we update the queue to communicate with the main program and say, hey, let's update the screen. So the main thread then checks the update queue. It's like, hey, what's going on? Do I need to update the screen? And then it says, yes, I need to update the screen. So then it's going to update the screen unless the queue is empty. So there just needs to be something in the queue. As long as it's not empty, it's going to update it. And that's why this can be anything. Hopefully this will result in a smooth movement of your character across the screen with no freezing. It's not a game platform, but it's kind of a fun way to learn about queues. We're using the async function, and when you have the async here in the def here, so it says you can run whatever is in here, but don't block other people. Everybody just does their own thing, and this one function will do its main thing, and it's not going to block the other functions on there, right? And that's the whole point, is that each thread can do the thing that it wants to do without blocking the other threads. However, if you want to pause what's going on in the thread, you want to pause this one thread, you do have to use the await keyword, and then it will pause it for this specific thread. So there was a difference, right? In the first, if it's synchronous, it's time.sleep, and then if we want to just block the thread, it's just await async.sleep. So not too much more difficult, right? You just have to refer to it and get used to the syntax, and then suddenly you're an async IO programmer. That's all there is to it. So with this, the UI can still respond to the clicks, and other code can run, and everybody's happy. And we're using get, don't wait. Don't wait, just go ahead and get it. Why are we using get, no wait? Well, if we use get, it would wait for the item to be available, which would block the async function. And we want the async function, which is Corey moving all across the screen, to just keep on moving and not wait. So that's why we're using get, no wait. It doesn't block Corey from updating his position movement. So we have the big 3, the state, the thread, and the async function. The state holds the current direction. We're using a Python dictionary for a rudimentary form of state. we have the thread that checks the state, it moves the character, and sends a signal to the queue. And then the async function checks the queue, updates that UI. So the flow is you press the button, updates the state, it creates a thread, it puts it on the queue, runs the async function, updates the UI. So this is a pretty common pattern in game development or real-time applications or professional software. And in fact, one of the reasons we're using Flat with async is because our other course, the Fast API, Fast Op, it uses async IO. And there's a whole bunch of reasons why you want to use async in Python. We're not going to get into it right now. It's just like you used it, congratulations, you are now an async IO programmer.